Hello, my name is Soham Datta. I am going to explain the experiment decay of current in a capacitive circuit. The objective is to study the decay of current with time in RC circuit and to determine the time constant of the circuit. Then we'll compare the observed time constant with the theoretical time constant. Now, in this, we will require certain apparatus like a capacitor, an ammeter, a power supply, some connecting wires, a breadboard, uh, the key which can be plugged in and plugged out, and it will act as a key switch. Uh, Now, mainly um, here we will study the decay of current um, in a capacitive circuit when in two cases. In the first case, there will be a battery which will be providing energy and a resistor um, uh, which will be degrading the energy, and in that case the decay of current will be observed, and in the second case there will be only decay of current due to a capacitor and a resistor. Now, in the first case, that is in the case of charging, we will uh, set up the experiment in such a way using the key that we will have only a battery, resistor and a capacitor in the main circuit. Now, what happens is, initially the capacitor has zero charge on it, but as the time uh, time increases, the charge starts getting accumulating on the capacitor, and the capacitor starts getting um, uh, in the growth of charge in the RC circuit. What happens is, initially we have a battery which is supplying voltage to the whole circuit, and the capacitor has zero charge initially. So the capacitors on the capacitor starts accumulating charge on it due to the supply by the battery, and eventually when it starts gathering charge, then the net voltage of the circuit starts decreasing, because voltage will be like V naught minus Q by C, and since V naught is constant and Q by C is increasing, so the net voltage starts decreasing. And since current is equal to V naught minus Q by C by R, that is R stands for resistance, C stands for capacitance of the circuit, and Q for the instantaneous charge on the capacitor, hence the current of the circuit also decreases, and this decrease is exponential in nature, which can be found out after integrating the function, uh, and this equation I is equal to V naught minus Q by C by R can be found out by writing the KVL for the entire circuit. So current is decreasing, and in the second scenario, when in the circuit only has the charged capacitor and the resistor, that time what happens is the resistor is extracting the is actually taking the energy stored in the capacitor. As a result, what is happening, there is decay of charge in the capacitor, and since the voltage of the capacitor is given by Q by C, and that is the voltage and by KVL we can easily see Q by C will be equal to IR, and since Q is decreasing, I will also be decreasing in that nature. Again, after integrating I is equal to minus dq by dt, we can find that it is exponential in nature. So in both the cases, the current will be decreasing exponentially. Now the main motive is to calculate the time constant and to check the deviation of the theoretical from the observed values in both the cases of charging and discharging by drawing a graph of linear regression. Now for linear regression we need a linear equation, and for linear equation we will draw a graph with y as lni and x as time. Now we know that I is equal to I naught e to the power minus t by tau, so we'll take natural log on both sides and we'll draw the graph, and we can see the formula for the graph where we will compare y is equal to lni and x is equal to t, and we'll use the linear regression formula and draw the graph, and we will check the deviation. After drawing the graph we will calculate the error. Now for error we will use this formula, and for error we will check the error in the time constant, that is we'll mainly find out d tau. So for error we'll by first we will make a formula of tau, then take ln on both sides. First we'll find out the tau as a function of the other variables, then we'll take ln on both sides and differentiate. After differentiating we can find out the error. Now di and dt will be required, which will be the respective least counts of the stop. For di we'll need the least count of the ammeter, and for dt we'll need the least count of the stopwatch, and plugging in the values will give us the d tau. Now so our final observed value will be tau plus d tau, and from the theoretical value tau should be 48.4 seconds, and then we'll compare our theoretical values of tau with two observed values, that is one obtained in the case of charging and the other obtained in the case of discharging, and to conclude our experiment.